We're going to pick up where we left off yesterday, trying to give you some ideas of how to solve these. The key is every problem's different, right? So probably the hardest part is being able to pick out that first step. What direction do we want to take? No. First of all, this is equals.
You can't cancel it because that's the answer.
Okay, now, so let's remember, this is a proof. So what are we starting with?
Cosine t over 1 minus sine t.
Cosine t over 1 minus sine t. And our job is to get it to equal 1 plus sine t over cosine t. But you can only cross cancel when we're talking multiplying.
Yeah.
Okay.
That's right.
So, options, thoughts. There's no squareds, so I can't think Pythagorean identity. It's already all in sines and cosines.
Common denominator.
There's only one fraction.
Oh, well.
Okay, so this is a new trick. Okay, this is a new trick. You see it throughout math in different, not just in trig. But that denominator is 1 minus sine t. We use this when we rationalize, when we're trying to get rid of a square root out of a denominator, and there's two terms, where we multiply by the conjugate. What is the conjugate of 1 minus sine t?
1 plus sine t.
1 plus sine t. So, we're going to multiply the denominator by 1 plus sine t. And you know what I'm going to say next, yes?
Yes.
What's that? Okay.
Same thing both places.
What we do to the denominator, we're doing to the numerator. So we're multiplying by 1 plus sine t. Okay. On top. As I sit there and think, do I want to multiply those or do I want to leave them? I'm currently not seeing...
I say we leave them.
Honestly.
I'm currently not seeing any benefit, and I'm trying to think ahead. Yeah, I'm not seeing any benefit, and it's one of those things. You got a 50-50 shot. Do I distribute and multiply them together? Do I not? I often tend to multiply the numerator together.
I'm just not feeling it.
Not this time. Now, what about the denominator? Multiply them together. They're conjugates.
Sine squared t minus 1.
Okay. I'm going to reverse that. 1 times 1 is going to be 1. And then middles cancel. Minus sine squared t. Does it make a difference?
Yeah. Sophie's
Slightly in our next step.
Oh, you were wrong.
Okay.
Slow it down.
Now, where's next? Yeah. Now that we have a squared, let's think about our Pythagorean identity with the idea that what? Sine squared theta plus cosine squared theta is 1. And so what do we need? We need a 1 minus sine squared theta. So if we subtract that over, I'm going to have cosine squared theta can replace 1 minus sine squared theta.
So then on the bottom it'll be cosine.
So every place I see a 1 minus sine squared, it becomes cosine squared. So cosine t times 1 plus sine t stays on top. My denominator becomes cosine squared t. And that is because we have a Pythagorean identity. Okay, so we have 1 cosine on top, cancels with 1 cosine on bottom.
Yeah.
That leaves us with 1 plus sine t over cosine t, which is our goal. I just had it way written down the page, and I can't leave that big
So
gap.
I did the same thing.
Yeah.
It's really big.
So, and here's what I'm going to say, guys. You don't have to write this down at the bottom because it does have to move sometimes. You know, and I'll be honest, like if I'm doing my notes and I'm using pen in my notes, I tend to like write it real lightly in pencil, like, you know. So you don't have to write this, just know where your goal is, right? Okay. So keep that trick in the back of your mind, multiplying by the conjugate. It's a trick that comes up in multiple places of math. This is not the first place you've seen it, because rationalizing a denominator, if you have like 2 minus square root of 3, to get rid of that square root, we multiply by the conjugate. So, okay. One more to try? Okay. We are starting with cotangent squared u over 1 plus cosecant u. And our goal is to make it cotangent u times secant u minus tangent u.
Let's just stare at it for a second. Do we have to multiply by the conjugate again?
Well, that's a really good question.
That's what it seems like.
Because,
that's what it seems like.
okay, and here's the
What
thing.
does Zach get us?
I did not do that in my notes, but I feel like it was really difficult in my notes. So give me pause for a moment.
Okay.
Well,
It is.
what's going to be better for all of us is if I know where this is going for sure. Because I just had that exact same thought of, maybe we should do a conjugate here. Because I feel like this is actually going to work better.
Oh, it very much does. Okay, it very much does.
1 minus cosecant squared. Is that cotangent squared?
Oh, really?
Is that the right?
No,
No.
secant.
So 1 minus cosecant.
Secant is the one.
Yeah, that would-
Okay, I'm getting there in a different sense. Okay. Okay. It didn't work out like I hoped it did, but we can still go that route. I see 2 different routes we could go.
Easier that way?
I think we still end up with the difficult, what I think is going to be the difficult ending to see. Personal opinion. Hopefully you guys will surprise
What's
me.
your personal?
So, now, I could go one of 2 ways with this. You guys suggested multiplying by the conjugate. I could do that. That could do things for us. The other option that I originally went, and again, they're both good. They're both going to be about the same amount of work, is I took that cotangent squared and I changed it out. What would cotangent squared be equal to?
Cosine squared over sine squared?
No? Think about how it could relate to your denominator.
Cosecant squared minus.
Cosecant squared minus 1, and cosecant squared minus 1 can factor. Now, I'm seeing some puzzled looks, so
I see it.
conjugate might be the better way to go.
No.
It's one of those, you know.
Okay. Yeah. Yeah. I see it. I see it, and you don't.
Let's
That's
go
crazy.
Mario.
No, I just started the other way, Mario.
That's crazy.
Well, that's a you problem, not an us problem.
I wasn't talking.
Now, go with your other way. You'll meet me here we're going to kind of meet in the middle, and then we'll still have to finish the end together.
Okay.
Okay, So, conjugate is an option. Other option that I saw is I took cotangent squared, which, what is the PI for cotangent squared? I always have to stop and think about these. It's 1 plus,
1 plus cotangent squared theta equals cosecant squared.
thank you. I always have to stop and think about these, even to this day. Okay, so it's 1 plus cotangent squared theta equals cosecant squared theta. So cotangent squared theta is cosecant squared theta minus 1. Okay, let's replace that. So I'm going to have cosecant squared theta, whoops, we're not in theta, are we? U minus 1 over 1 plus cosecant u. What does that numerator do? Denominator is going to stay the same for right now. The numerator is of the form of what? X squared minus 1. Can you factor x squared minus 1? I hope so if you've made it this far in math. X plus 1, x minus 1, right? So cosecant squared u can factor into cosecant u plus 1 and cosecant u minus 1. What can happen?
The first one, bottom tangent.
Cosecant u plus 1 is the same thing as 1 plus cosecant u, yes? So now I have cosecant u minus 1.
Well, that's pretty good.
And unfortunately, it doesn't really look a whole lot like where we need to go. Now, if you went the other way and multiplied by a conjugate, you're going to end up in a similar position here.
I erased it because
Okay.
it was just too much.
It does work, I promise. It does. But it wasn't any better, so. Okay, so this is the, where do we go now?
So where do we go now?
Yeah.
Where do we go?
Cosecant u minus 1 needs to magically become cotangent u times secant u minus tangent u. So,
Stuck in there.
I don't really see the connection. Just like you guys don't, right? So, I went with the idea of everything can go to sines and cosines, right? So I started with that. Cosecant u is going to be 1 over sine u. And then it's minus 1, yes? Again, this one's rough. This one, there's a lot you have to see.
I can do you. I can't do you.
Then don't do the u.
I don't like the
Pick a different variable.
I know. Usually I change it to X, but I was like, maybe I'll try it for this one. I can't.
Now,
Not loving
on this, in an attempt to get some more pieces in here, I believe, if I recall, I looked for a common denominator so I could put these together as one fraction. What would the common denominator be? It would be sine, yes? So what is 1 with a common denominator of sine? 1 is going to be what?
sine.
It's going to be sine over sine, right? Because if you multiply 1 by sine over sine, it's still 1. And so when I do that, how many steps do I want to write out here? I mean, you're thinking 1 over sine u minus sine u over sine u, yes? When I put that together as one fraction, it's 1 minus sine u over sine u. Okay. At this point, and again, I'm definitely not going to argue this is the only way to do this problem. There could definitely be other better ways, but I just haven't found it. here's what I noticed. I'm going to have parentheses that are something minus something. I have a something minus something. I'm going to need a cotangent out front. What do we know about cotangent?
Cosine over sine.
It's cosine over sine. What do I currently have in the denominator? A sine. For a cosine, I need a cosine over sine. Do I have a cosine in the numerator? No. How can I multiply in a cosine in the numerator? I can multiply a cosine in the numerator as long as I multiply a cosine into the denominator as well. The idea is, if you're going to multiply a fraction by something, you can multiply that fraction by anything you want as long as it's equivalent to 1. So here's the idea I went with. Let me pick a different color. Is I multiplied numerator and denominator by cosine u. And I think I'm going to sidestep here because I'm not going to squeeze it in there. Are you seeing this? So now, if I don't multiply these together, on top, I'm going to have cosine u times 1 minus sine u over sine u times cosine u. Now, and this is where I personally start seeing it. That's me. I'm not expecting 100% from you guys. One of our tricks is to separate fractions. We don't use a lot, but one of our tricks is to separate fractions. You see this right here, yes?
Yeah.
So I can separate this out as cosine u over sine u. And I can do this because it's all just times, right? Times 1 minus sine u over cosine u. Cosine u over sine u is the cotangent we were so desperately looking for. A denominator in a fraction goes with each term in the numerator. So more separating. So I'm going to write this 1 over cosine u minus sine u over cosine u. Do we have what we need? Cotangent u is already out front. 1 over cosine u is secant u minus sine u over cosine u is tangent u. Took some work, but we got there. If you find a more direct route, I'm more than willing to consider it, but I don't have a more direct route. Sometimes you have to kind of work around. Okay. Your homework is page 411, yes? I have it written as 12 through 39, multiples of 3. You can't handle that. Then you write on your paper 12, 15, 18, 21, 24, 27, 30, 33, 36, 39.
Me personally, I'll pass it right now.
There's a reason I wrote it on the board as 12 through 39, multiples of 3.
Only 10 questions.
I think so.
That's nice, but when you're so hard at this.
Okay. So, there's your homework. You have some work time. Use it. Okay. We will come back tomorrow and talk questions and turn it in. Okay.
Did you get a question?
Yeah.